Welcome to Soil Science and Management, Chapter 12. And in this section, we're going to be discussing plant nutrition. We've already discussed some of this, but we are going to focus on the primary macronutrients and how they move around, and namely the nitrogen cycle. And then we'll be discussing a bit of the secondary nutrients and then some of the trace elements as well. Nitrogen is obviously the most important nutrient that is had for plant growth. And when we are discussing nitrogen, basically these sources of nitrogen are used for fast growth. It can provide a robust root system. Its main purpose is for improved photosynthesis, and it allows the plant to use its carbohydrates and convert proteins much faster. If you were to use this and you were to look at, say, grass, it basically creates a lush top growth of grass and more productive crops. So this is a nutrient that helps with the vegetative growth of plants. So what happens when you put too much nitrogen down? And it's basically you can be susceptible to insects and disease because the plant is growing so fast that it's opening itself up for like infections. It doesn't allow for fruiting of plants as readily. So as I said, the nitrogen is for vegetative growth, not necessarily for fruiting growth. So there is a time in the growing of plants that nitrogen is supposed to be tailed off, and phosphorus and potassium are increased. And then nitrogen can impart certain flavors on certain plants and certain fruits and vegetables. So the nitrogen cycle it's basically very similar to all the other cycles: the carbon cycle, the water cycle. It is the continued loss and gain of nitrogen through all the systems, through nitrification, ammonification, and then back out into the atmosphere. So there are several things, and obviously there's a figure of this in the book, so I'm not going to talk about it too much, but this is very important to understand how the nitrogen cycle works. When you are growing crops, you are increasing your nitrogen loss, so you're harvesting away a lot of the nitrogen. So as you harvest away the vegetative growth, you are taking that nitrogen out of the equation. You are leaching it through the system. If you are using lime, you are removing the nitrogen from the being easily accessed by plants. There are three different forms of nitrogen in your soil. The first form is organic matter. The second form is ammonium, or NH4. The third is nitrate, or NO3. So these three forms are the only forms that can be utilized by plants in the soil, and namely ammonium and nitrate are the forms that are most readily available. And these are formed through the ammonification and nitrification cycle within the soil. So I said NH4, ammonium. There is also ammonia, which is NH3, which can be toxic to plants within your soil. And then I also said nitrate, which is NO3, but there is also nitrite, which is NO2, which can also be highly toxic to plants. And these two compounds are formed with the a short circuiting of the ammonification and nitrification process, and they are taken too far, and these processes are to the detriment of the plant. So what does a nitrogen deficiency look like? These are slower growth, stunting, and a chlorosis. Or chlorosis basically is the dying back of leaf tissue, and so this will be a yellowing of the leaf. And then firing, which is basically the drying up of leaves, and this will happen on the older leaves as opposed to the new leaves. The plant starts to sacrifice older leaves if it has a lack of nitrogen. Moving on to phosphorus. So phosphorus is part of reproduction and cell division. It's very important in cell membrane integrity and function. It is really good for early growth. Phosphorus is used in seed during seeding to improve early root growth. When you're using phosphorus the right way, it will help with your water efficiency, and it will provide the plant resistance to cold, and it will make it strong enough to resist disease. So things that can be happening due to lack of phosphorus is stunted growth, and one of the telltale signs of a lack of phosphorus is purple plants. So if you start to see a purple coloring in plants, then you probably have a phosphorus deficiency. There are several forms of phosphorus in the soil, and these are calcium phosphate, organophosphate, clay particles. Now, one thing about phosphorus, it's very immobile in the soil, so it does not move around readily. These are hard elements to for plants to find. So plants have to really work for the phosphorus. So it's good to have phosphorus readily available for a plant. As I said, phosphorus moves very slowly within the soil, and this can be affected by pH, because the phosphorus will become unavailable. Soil moisture due to lack of movement. So obviously we need to have moisture to move these products within the soil. If there is a lack of oxygen or the soil is not warm enough, then we have a problem with the phosphorus not being able to be taken up. And one of the ways we've talked about in the past is this mycorrhizal relationship between plants and the soil. If this is lacking in the soil, that can help cause these deficiencies, because the mycorrhizal will move around and look for the phosphorus, and it will help gather that for the plant, so it's able to be moved. It's able to move itself around more readily, find the phosphorus, and then help the plant uptake that phosphorus. When we have deficiencies, we have stunting and fewer or smaller leaves, a purple tint to the leaves. These will be on the lower, older leaves, and then the delayed maturity in crops, because I've always been taught when you start to see fruit, you start to throw phosphorus. You start to really push that phosphorus because it will help your fruit grow bigger, will help impart sugars into the fruit, and this is when you're going to want to do that. And then potassium is helps to open and close the stomata, and it regulates the osmosis process. These can be common minerals in clays. You have muriate of potash, which is the most common form of potassium. This is very easily moved within the soil, but not quite as easily as nitrogen, but is not as big an issue as the phosphorus. And it's also really easy to keep potassium in the soil if you have adequate potassium. In the turf industry, for example, one of the best ways to keep potassium within your soil is to recombine your clippings or cuttings back into the soil. Another great way to do to maintain your potassium levels is to use lots of compost. because the compost will break down and the potassium will be readily available through the composting process. Potassium deficiencies result in slow uptake. There's a scorching of the outside of the leaves, and then weak stems, and you'll have droopy leaves because of a lack of potassium. So the secondary macronutrients is, first we'll start with calcium. Calcium is used to build strong cell walls and membranes. It is helped to form the formation and of stress protective proteins. So basically, just like us, calcium makes the plant stronger. The problems with calcium is it can have storage problems. Telltale sign in tomatoes is blossom end rot, which will be a black rotting on the underside of the tomato. And you can also have bitter pits in apples, and it's called brack burnt, and it basically will create a black heart on like colorful plants. So the poinsettias, celery, lilies. Next, we have magnesium. This is one of the metals that is important for plants. Very important for chlorophyll production. It helps uptake of other nutrients in water. It also activates enzymes within the plant. When you don't have enough magnesium in a plant, the plant tends to be susceptible to droughts, cold, and disease. Pretty telltale sign of this is interveinal chlorosis, or a mottling of a leaf. Basically, it will look like the vein is nice and dark green, but everywhere else upon the leaf starts to turn yellow. Sulfur, this is a very essential part of the chlorophyll making process, which is essential to photosynthesis. It also helps to fixate nitrogen in legume plants, helps to improve stress tolerance within a plant. Sulfur will make sure your vegetables taste good. If it's pretty funny, if you don't have the right kind of sulfur, the right amount of sulfur, it will make your vegetables taste very bland. And if you've ever said, "Oh, what is this wrong with this tomato?" It's potentially that there wasn't enough sulfur while it was growing. Some of the problems are pale leaf color, so this will almost be like a lime green or olive leaf color on plants, and then stunted growth. So the metallic trace elements, this is your iron, your manganese, your zinc, your copper, your nickel. We talked about this in the previous couple of chapters. These are more micronutrients, so they're trace elements within the ground, and a lot of these are very dependent upon the soil's pH level for uptake. And the issue with most of these is they can be very toxic if they are in excess. So they are required, but you have to be very careful when applying them. Typically, these are applied in chelate form so that they are a slow release fertilizer. These anionic trace elements, boron. So basically, boron is, there's not much known about it. It's in such a small quantity that it's very rarely ever added to a soil. And if it's in too high a quantity, it can be highly toxic to a plant. We also have molybdenum and chlorine. Molybdenum is used for nitrogen metabolism and nitrogen fixation. Again, these are very, very small trace elements. The chlorine does not get added in again, and it does play a role in photosynthesis. This usually is part of water as it comes through, so it's not really ever added or needed. but in high quantities can be toxic. The nice thing about chlorine, though, is it off gases quite quickly, so it does not cause issues unless there is a heavily concentrated air formation of chlorine. Then we have three beneficial elements. Those are cobalt, silicon, and sodium. So in summary, we learned about the different mineral elements. This is a somewhat of a review for soil fertility, but does go into more depth on these varying elements. There's a lot more to this, and we will learn a lot more about these elements and how they interact with the plants and with soil. So stay tuned.